Let me paint you a picture. The year is 2022, and the world of AI is in the middle of this colossal arms race. The mantra, the one rule that everyone believed, was super simple. To build a smarter AI, you just had to build a bigger AI. It was this mad dash to the top, a competition measured in billions of parameters. The sky was the limit, and everybody was just building bigger and bigger.
And I mean, you had these absolute monsters entering the ring. You had Google's Gopher, a real heavyweight at 280 billion parameters. And then you had things like Megatron, Turing, and LG, tipping the scales at a mind-boggling 530 billion. These weren't just computer programs, they were like digital skyscrapers, built on this one single idea: size equals intelligence.
But here's the thing. What if that one core idea was just wrong? What if the entire industry was pouring billions of dollars into climbing the wrong mountain? In early 2022, a few researchers at DeepMind dropped a paper that basically asked that exact question. And, well, their answer was about to change everything.
Okay, so to really get why this was such a big deal, you have to understand the one thing that limits pretty much all AI development: the compute budget. We're talking about the raw cost of training these models. It's millions, sometimes tens of millions of dollars. It's not an infinite resource. So it all boils down to this one huge billion-dollar question: how do you spend that money in the absolute smartest way?
I love this way of thinking about it. Just imagine your entire budget is a fixed pile of gold. You've got two main ways you can spend it. You can use your gold to forge a bigger, more complex brain for your AI. That's the model size. Or you can use it to buy a massive library of books for it to read. That's the training data. Here's the catch. You can't have both. The bigger the brain, the smaller the library. So, what do you do?
All right, let's just quickly get on the same page with the terms. When we talk about parameters, think of them as the connections in the AI's brain, the little knobs and dials it can tune. More parameters means a more powerful, more complex brain. And tokens? That's just the stuff it learns from. Words, pieces of words, that's its library. So the whole game is about this trade-off. Do you spend your budget on more brain connections or on more books for the library?
Now, before this new paper came along, the industry's rulebook was basically written by a 2020 paper from Kaplan and his team. And their research pointed in one clear direction. If you have more money to spend, you should overwhelmingly spend it on making the model bigger, on the parameters. They figured you got way more bang for your buck by building a bigger brain than by buying more books. And for a while, this was gospel. It was the rule everyone followed.
But the researchers behind this new paper, they had a hunch that maybe, just maybe, that rule was a bit off. And to prove it, they didn't just go and build one more giant, expensive model. No, they did something way, way smarter to find the true golden ratio between the brain and the library.
And this is the brilliant part. Instead of baking one huge, risky million-dollar cake, they were like master chefs. They baked over 400 different cupcakes. They tried all sorts of recipes, systematically changing the amount of flour, the model size, and the amount of sugar, the training data. By doing this, they could map out the entire performance landscape and find the absolute perfect, most efficient recipe for any budget. And what they found? Well, it was stunningly simple and totally revolutionary. The secret recipe wasn't to throw all your money at the brain. It was to grow the brain and the library in perfect harmony. For every time you doubled the model's size, you should also double the amount of training data. A perfect, balanced, one-to-one ratio.
And just look at the difference here. The old rule was so lopsided, right? Heavily skewed towards model size. But the new rule, Chinchilla's rule, it's perfectly symmetrical. What this really suggested was that the entire industry had been building these AIs. They were all brain and not enough books. They were oversized, and more importantly, they were seriously undereducated.
Okay, so making a bold claim like that is one thing. You gotta back it up. So the researchers put their new recipe to the ultimate test. They built a model using their new rules, and they decided to pit it against the reigning champion Gopher in a head-to-head showdown. And this is a classic underdog story, a real David versus Goliath. In this corner, you've got Goliath, Gopher, with its hulking 280 billion parameter brain. And in the other corner, you have David, the new model they named Chinchilla, with just 70 billion parameters. I mean, it was 4 times smaller. On paper, this shouldn't have even been a contest. But, and this is the most important detail of this entire story, this was a fair fight. Both models were created using the exact same amount of compute, the same pile of gold. Gopher spent its budget on a giant brain and a pretty standard-sized library.
Chinchilla spent its budget on a smaller, more efficient brain, but used the savings to buy a library that was 4 times larger. We're talking 1.4 trillion tokens of data.
So, the moment of truth. How did they do? Well, let's look. The MLU benchmark is basically a giant, brutal exam for AIs, covering 57 different subjects. Gopher scored a pretty good 60%. But Chinchilla, the tiny one, it blew it out of the water with 67.6%. That is a massive difference.
And the story just keeps going. On reading comprehension, using questions from actual high school exams, Gopher got about 71%. Chinchilla, a staggering 82%. It wasn't just a little bit better, it was in a completely different class.
And it just kept winning. Common sense reasoning? Chinchilla outperformed Gopher. Again, test after test, the result was the same. The smaller, data-rich model consistently and clearly beat its bigger, data-starved rival. The underdog had won, and it wasn't even close.
You can just imagine the shockwave this sent through the AI community. This wasn't just some new record on a benchmark. This was a fundamental shift in how to think about building AI. The paper basically proved that the path to smarter AI wasn't just about raw size. It was about the balance between size and data.
In this one quote from the paper, it just says it all. All those giants, GPT-3, Gopher, Megatron, they were all, in the paper's words, significantly undertrained. It's like they were building these incredible geniuses who had never been to a library. They had the brain power, but they hadn't been given enough knowledge to fill it.
The legacy of this, what we can call the Chinchilla effect, was just profound. First, it showed you could get smarter models for the exact same cost. Plus, because these new, optimal models were smaller, they were cheaper to actually use day to day. And almost overnight, the entire industry pivoted. The obsession shifted away from just model size to a whole new appreciation for the quantity and, just as important, the quality of data.
So, when you boil this whole incredible story down, what's the big takeaway? In this super complex equation of how to build AI, the Chinchilla paper proved that we had been getting one of the variables completely wrong. The real winner, the secret ingredient that we had been undervaluing all along, was the data.
And that leaves us with this really fascinating thought, doesn't it? For years, the story of AI progress was this race to build the biggest digital brain imaginable. Chinchilla proved that was the wrong race to be running. It makes you wonder, now that the obsession with brain size is over, has the real competition, the race to find and curate the biggest, best, and cleanest libraries of knowledge, has that race only just begun?